So hopefully that last example made sense. We have 3 more that I want to go through. So at noon, ship A is 150 kilometers east of ship B. Ship A is sailing west at 35 kilometers per hour, and ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.? So I'm going to draw here. Ship A is sailing west. So ship A here, this is ship A, is going west at 35 kilometers per hour. I'm going to just write a little note here to myself. And ship B is sailing north. Ship B is sailing north at, what does it say there? 25 kilometers per hour. And ship A is 150 kilometers east of ship B. Well, that means if ship B is on the y-axis, ship A is going to be 150 kilometers minus the x value, right? So let me look at this. Okay, so this problem is a little bit more complicated, but it's okay, we can definitely do it. We know that this value here is going to be z, right? I wrote z squared, which will become eventually. But we also know, and we've written this before, that x squared plus y squared is equal to z squared, right? And we're given, well, we're given that ship A, so dA over dt, is changing at 35 kilometers per hour, and dB over dt is changing at 25 kilometers per hour. And actually, maybe I should, make this a little clearer here. This is our x, dx, and dy. Oh, dx, dy. Okay, x, y, x, y. It's really messy looking, but hopefully you can see it. So we want to find dz over dt when t is equal to 4, right? That's what we're trying to find here. So let's set up this equation. We actually know x squared plus y squared equals z squared. Well, our x value is not just equal to x, it's equal to 150. So I'm going to write down 150 minus x quantity squared plus y squared is equal to z squared. Now I need to find my derivative here. So I'm going to have 2 times 150 minus x times negative 1 times, cannot forget the most important part here, dx over dt plus 2y times dy over dt is equal to 2z times dz over dt. All right? Well, we know when t is equal to 4, we need to find our x, our y, and our z, right? So when t is equal to 4, x is going to be equal to, okay, before we dive into that, we know that distance is equal to, I keep mistake writing here, distance is equal to rate times time, right? So our x distance is going to be equal to the rate, 35, times 4. This is all happening when t is equal to 4. So that's going to be equal to 35 times 4, which is 140. And y is going to be equal to, our rate is 25 times 4, which is equal to 100. Well, z is going to be equal to the square root of 150 minus 140 squared plus 100 squared, which is equal to the square root of 100 plus 10,000, which is equal to the square root of 100 plus 101, or not plus, but times, excuse me, times 101, which is equal to 10 radical 101. That's our z value. So we're going to use that. I'm going to go back over here, so because we're trying to find this at t is equal to 4. So we have 2 times 150 minus 140 times negative 1 times, remember our dx is 35, plus 2 times 100 times 25 is equal to 2 times 10 radical 101 times dz over dt. Well, that's exactly what we're trying to find, was dz over dt. So I'm not going to work through all of this. Hopefully you can just trust me, but you can do the math yourself. We have a negative 350 plus 2500 is equal to 10 radical 101 dz over dt. So 2150 over 10 radical 101 is equal to dz over dt. And if I simplify this, I get 215 over the square root of 101 kilometers per hour. I wrote per meter, but that's not correct. Per hour. That's our change in z with respect to t. All right. A little more complicated, but we've got two more that we're going to work through and kind of solve those. All right. A right circular cylinder is changing shape. The radius is decreasing at a rate of 5 inches per second. When the radius is 4 inches and the height is 6 inches, how fast is the volume changing? And actually, with this problem, we were given that the volume of a cylinder is equal to pi r squared h. That's very nice and convenient. So we're given that, and we also are given that, so we know volume is pi r squared h, and we're also given that dr over dt is equal to 5 inches per second, and dh, the radius is decreasing at a rate of 5 inches per second. Oops, 1 second, I have a typo in here. Okay, I fixed it. So if the radius is decreasing at a rate of 2 inches per second, while its height is increasing at the rate of 5 inches per second. When the radius is 4 inches and the height is 6 inches, how fast is the volume changing? That's plenty of information now. Well, dr over dt is going to be negative 2 inches per second. And dh over dt is going to be 6 inches per second. So, oh, not 6, 5. Gosh, I must be tired at the end of the day to do this. 5 inches per second. So we're going to find dv over dt. We want to find dv over dt when r is equal to 4 and h is equal to 6, right? So we need to find our derivative. So I'll do it here, I guess. dv over dt is equal to 2 pi r. Well, you can see here that we have two variables, r squared h. So we need to actually use some product rule, right? So I'm going to say pi r squared times dh over dt plus h times 2 pi r times dr over dt. Very exciting. And I'm just going to actually leave that there. dv over dt when r equals 4 and h equals 6 is going to be equal to pi times 4 squared times dh dt is 5 plus h is 6 times 2 pi times 4 times negative 2. Why is it negative 2? Because it's decreasing. It indicates direction. So then we're going to have 16 times 5. 16 times 5 is 80. So we have 80 pi minus 2 times 4 times 2 times 6 is 96 pi. So it looks to me like we have a negative 16 pi inches cubed, because we're talking about volume here, per second. That's our dv over dt. That's kind of a fun problem. All right, last one. I'm sure you're kind of getting a little tired of these, but they are important, and they are very, very common free response questions, so they're important to know. An inverted cone is leaking water at a rate of 1 centimeter cubed per minute. The cone has a height of 9 centimeters and a diameter of 6 centimeters. Find the rate at which the water level is dropping when h equals 3. Well, something to note here, our diameter is 6 centimeters, so I'm going to say my height, h, is equal to 9 centimeters. My radius, because I'm given my formula, is actually equal to 3 centimeters. That's something to watch out for so that you don't get tricked there. we want to find the rate at which we're given this. We're also given that the rate at which leaking water, so we're given that dV over dt is equal to -1 centimeters cubed per minute, right? It's a leaking one. And we want to find dH over dt, rate at which at h equals 3. Okay, so let's do that. So V is equal to 1/3 pi r squared h. So dV over dt is equal to, we're going to do some product rule here, 1/3 pi r squared times dH over dt plus h times 2/3 pi r dr over dt. All right, so we got a lot of stuff going on here. It's kind of ugly, but we can figure this out. Okay, before we can keep doing this, I'm given my h, but I don't have an r. I don't have a value for that, so I need to be able to find r in terms of h. So I'm going to just draw my cone here. All right, and here's my height h, and here's my radius r, right? So I know that my ratio of this cone is going to be that h is to r just as 9 is to 3, because I was given those for the height and diameter of the cone originally. So I can calculate this, and I know that h is equal to 9/3 r, or I know that r, which actually this is equal to 3, so h is equal to 3r, or I can say that r is equal to 3 over h. And actually, I think that might be easier to use when we're calculating this. So I'm going to go back here. So now I have dV over dt when h is equal to 3 and r is equal to 3 over h is going to be equal to 1/3 pi times 3 over h squared times dH over dt. And actually, I shouldn't even have written the dV over dt here, because that I already know, don't I? I know. Dang it. I'm going to pause it one more time. Okay. I really kind of got ahead of myself here when I did this. So I'm going to go back to this original formula. Ignore that. Come back here. So V is equal to 1/3 pi. And instead of r squared, I'm going to write 3 over h squared times h, right? So now I have 1/3 pi times 9 over h squared times h. This still doesn't look right. Son of a... Okay, students, I'm learning my lesson. Don't do this at the end of the day anymore. Here's my problem. R is not equal to 3 over h. R is equal to h over 3. So now, V is equal to 1/3 pi times h over 3 squared times h. So V is equal to 1/3 times pi h cubed, and this is over 9. So V is equal to pi over 27 h cubed. Now, this is where I'm going to take my implicit differentiation. So dV over dt is equal to 3 over 27 pi h squared times dH over dt. So -1 is equal to 3 over 27 pi times, and we're using this when h is equal to 3, so times 9 times dH over dt. So 9, this is 27, 27, this just becomes 1, right? So this is -1 over pi is equal to dH over dt. So dH over dt is equal to -1 over pi centimeters per minute. And if you want to, this is about -1 divided by pi is about -0.318 centimeters per minute. All right, I really made a mess of that last one, so I apologize for that. Hopefully you can kind of work through it all. We're going to talk about these in class, kind of take it slow. Any questions that you have, leave them in the comments, and I will see you in class. Bye!